Next, we have Statsig's very own data scientist, Liz Obermaier, with 100 experiments to run before you die.
Hi, everyone. I'm so excited to talk to you all today about 10 experiments to run before you die. I think that when we think about experimentation, sometimes we just think about what we do currently or what we've done in the past, but we actually have a lot of tools at our disposal to be able to do different things in different circumstances, to be able to speed things up, and use a wide variety of techniques to fit the circumstance that we have. Obviously, I work at Statsig, an experimentation company, so I want you to run more experiments, but hopefully this talk is compelling enough that you're willing to look past my impure motives and keep experimenting, try new types of experimentation, and be able to just be really data-driven in what you're doing and be able to test everything. Before we begin, I wanted to share this quote attributed to George Box. All models are wrong, but some are useful. This is a very controversial quote I've found. Oftentimes when you bring this up, people are like, oh, so you're wrong all the time and you want me to think that it's going to be useful? But I think when we dig deeper into that, what we mean by this, by something being wrong, is we're making assumptions and we have a certain amount of uncertainty. It's not that it's inherently wrong. There's just a limit on what we know based on what we've observed, and we've had to make some assumptions in order to get there. And when we're talking about models, that means any of our causal inference methodologies, including experimentation. So when we're running experiments, inherently we are making assumptions, and we're getting results that aren't wrong per se, but they're uncertain. And so we need to be willing to make these assumptions, and we need to be willing to make do with this uncertainty. And we're going to have a trade-off whenever we're going to be more certain. It's because we've made more assumptions to get to that answer. The fewer assumptions we're willing to make, the less we're going to have precise answers, because those assumptions help us kind of narrow down and have more precision. So with that in mind, with me waxing poetic about models being wrong but them still being useful, I hope that that kind of sets the stage for what we really care about, and that's being able to use these to make decisions with and to better understand our product, and use those goals to understand what we're willing to assume and what levels of uncertainty we're willing to accept. When I talk about broader causal inference as a landscape where experimentation exists, I think the natural question is, why experiments in particular instead of just other causal models? I think that when we talk about other causal inference, it can get really tough, right? When we have diff and diff or propensity score matching, those are inherently assumptions in and of themselves. And it tends to sit further on the side of making assumptions so that we can be more certain. But obviously, in a lot of academia, in a lot of econometrics and economic research, we need to make those assumptions because we don't have the power of randomization. That's what makes experimentation so special, is because we have this power of randomization where we can assign different treatments to different users and then measure things instead of being stuck with observational studies. And randomization is so powerful because we get to use the expectation that differences among our population will net out, that we have this treatment, which is a really strong instrumental variable that explains our results. And so that's why experimentation is so nice, and in particular, we'll be focusing on experimentation. I have 3 different kinds of experiments that I'm going to talk about tonight. It really is just that, 10 experiments I'd like you to try running before you die. And I know, it's a little morbid, it's a little clickbaity, but we're going to start with our basic experiments. And while these are going to be the starting point for everyone, it's not that you graduate to more advanced experiments. You're probably still running them a lot of the time, and they will fit your needs most of the time. But there are certain situations where you might deal with things that don't normally happen and special situations where you need to be able to introduce more assumptions and measure things in a different way. And so those are going to be our hard questions that we talk about. And then finally, we'll have some jet fuel, things that help you go fast, things that help you make decisions more quickly, instead of a normal A/B test where you might have a fixed time that you're running things for. When we're talking about our basic experiments, like I said, these are going to be your bread and butter, and probably everyone is running these already. I think when we start talking about A/B testing, it's interesting to talk about what most A/B testing experiments are, which is growth experiments. We might have a variety of people who aren't in marketing here, but often marketing is a space where measuring the difference between two treatments is really important. Now, obviously, I'm not a marketer based on my treatments that I suggested, where you can sign up today, I'll give you, one tiny sliver of a Bitcoin, or I'll have an offer that expires, so I'm kind of using that as a carrot to try to get you to click on it. And we can measure the difference between these kinds of treatments, right? And what we're getting is kind of like a sign-up rate, and we're able to measure like how users are moving through these new kind of experiences that will actually get us to have an audience for our product as a whole. Now, we not only want to measure that we're getting people into our experiment, but there's also the other side effects that we want to measure. If we're looking at just these metrics, we're getting a bit of an incomplete picture. I'd love to hear from this audience, what other metrics would you want to measure in a growth experiment, other than just click-through rate, sign-up rate, and these kind of visitor statuses that we have that show if someone is interested in clicking through here? Does anyone have any ideas for other metrics? Session time, that's a great one, yes? Customer lifetime value, that's another great thing to measure, yes? Unsubscribe rate, exactly. Some of these, like unsubscribe rate, helps you understand, is it just a clickbaity thing that I got people to click, but then they don't really stick around? Customer lifetime value, that may take a long time to measure in an experiment, but it's really vital, data about your platform as a whole. So that's something that you might want to measure as well. I think you guys had great examples, and kind of the whole story of this is it's beyond just doing the basic part of making it further in a sign-up funnel, clicking in, subscribing once. We really do want to understand the full lifetime of the product, which is where we might use our standard A/B product tests. And what we would be doing in this circumstance is, building a new feature, using something with our audience as a whole, maybe adding notifications, and kind of continually trying to understand what keeps customers there, give them new things to use, and build that user base, other than just growing it. You don't want to be pouring more water into a leaky bucket, the same way you don't want to have great growth tactics with nothing to help users retain. I think that these are really commonplace, and they're probably what the bulk of people are doing on a daily basis. But that doesn't mean that they're just simple, and you don't need to think about all the different options you might have there. I think one of the major things to think about is it's not just UI changes, right? It might be algorithm changes. It might be performance changes that you still want to measure other impacts of, because as you make changes, inherently there will be bugs sometimes that you might not catch. There may be unexpected regressions. And it isn't just when a user is interacting with the UI that they might have a negative or positive experience with the product. When we think about your population, too, it might not just be users or devices, which we typically think of. For example, if you're a Statsig user, you've definitely been in one of my experiments, which is on the query level for some of our products, where we're trying to speed things up and assuming that faster queries are better. I think we can all agree faster is usually better, with the same results accuracy. And so that's another unit of experimentation that you can think of beyond just a user, a device, a geo. I think also avoiding messing things up. A lot of times when you're building products, you have a vision for how they go. And if you have a successful experiment, it's just confirming what you already thought, right? You thought this would be something helpful to users, and that happened. You might have some metrics to prove it now and say, hey, we should ship this. But it can be even more powerful when something unexpected happens, when there's a regression, maybe in a certain population, and you get that feedback loop to be able to iterate. And then, again, the reminder that measurement is not one size fits all. Like everyone was contributing in the audience to our previous analysis, it wasn't just the surface level metrics that we wanted to measure of success of one thing. It was the ongoing success and health of all of our users on the product, and not just one short-sighted thing. I'd love for anyone to tell me what they think this experiment is. Does anyone have any ideas for what we might be doing here? Yeah. Oh, an AA test. You know, you're right. It's really surprising results. This is obviously a super cherry-picked AA test that I kind of grabbed for shock value, right? But I think that it's really helpful to be able to understand, like, hey, am I reliably assigning random users to their control and test? Are my metrics going to be sensitive and helpful in this situation? Am I going to get a lot of false positives because I'm seeing these kinds of crazy results? It can be a really helpful barometer for if everything is set up right and if your code is working as you intended to. Like I said earlier, you need to be able to plan for unintended consequences, and an AA test is a way to understand if there's unintended consequences of your experimental setup itself. One of my favorite experiment types is holdouts and backtests. And I think these are becoming more and more powerful as people continue to ship code faster with things like AI agents speeding up how quickly they can produce code and ship things. It also impacts how much you need to have guardrails. One example of a holdback being really powerful is you can basically ship that feature you're really excited about and ship really rapidly to most of your users, but with a holdback, you can also understand over the long term what the health of that decision was, and if things aren't going as you expected to after a short time, you can change that decision and be able to reverse course in the case that you may have had a false positive, or you may have not paid attention to a novelty effect, or maybe the entire experiment that you run previously was a novelty effect. This just helps you kind of check your work and make sure that you're really building things that are long-term valuable to people. Another really cool outcome of holdouts is that you can look at the evolution over time of a pooled holdout, where they really do start as just an AA test if you haven't shipped anything. And then as time goes on, you can continue to observe how your changes kind of stack onto each other and understand the cumulative impact of a team, org, or the whole company, really. And it helps you understand the true impact of your experimentation program and what you've been shipping. When it comes to our hard questions that we're trying to address, a lot of the times it's going to be in specific circumstances. And this kind of is going to be something where you're going to look at the circumstances that you're in. You might say, hey, I don't think I can run an experiment, actually. But there might be some assumptions you can make, some tweaks you can make with assignment that'll allow you to run an experiment or allow you to use a different methodology. One example of that is in the case where there's interferences. I think the really example that everyone hears is, what if we do a marketing campaign out of house? What if we have billboards up? What if I am doing radio ads? How can I measure the impact of that? And how can I understand if it's truly moving the needle and what the ROI is? And this can be really tough to measure in an experimental context because that violates sattva, right? We're not able to treat individual units individually, and we're going to lack sample size if we say, oh, just the geographies that we put things up in are the units. We're going to end up with a lot of variance. One really powerful tool for this is using a synthetic control. Meta has a really famous package called geotesting. That's what we tend to use. But this really is just a description of a set of tools that you can use to be able to synthesize the counterfactual for what you're trying to measure in real time with your treatment, right? So a way that you can do this is Let's say I say that the vibe of Seattle is like if I mixed Portland, SF, and Boston all together. And I wanted to run an experiment that I thought would change the vibe of Seattle. What I could do is model Seattle's vibe after those 3 cities that I just named, not do anything there, but change my treatment in Seattle, and be able to understand the impact by comparing my counterfactual that I synthesized with a model and my observations of what actually happened to Seattle. And what that allows us to do is kind of be able to not worry about temporal effects, right? If I'm comparing this week to last week, that might be a perfectly fine thing to do at some points in time, but if I'm comparing Black Friday to the week before, in a lot of retail environments, that'd be crazy, and it would look like all of my out-of-home campaigns were incredible because I had so much more sales than the previous week, right? So it's all about understanding your context, what problems you're trying to solve for, and what's the best approach to use to kind of get around your inability to measure a true counterfactual, not have the sample size. Another way that you can deal with this same issue is using switchbacks. This is really made famous by Uber and Lyft, which tend to use this to test different algorithm changes because they have a marketplace, right? Any treatment that you provide to the rider is going to impact the drivers, which in turn impacts other riders, as well as vice versa. When you treat the drivers, it impacts their riders, which in turn impacts other drivers. So you have this kind of inextricable network effect where you might want to use switchbacks. The reason this works so well, or I guess in Uber and Lyft's case, is because when you go to that app, it's a very temporal thing that you might be doing, right? You're calling an Uber, you decide to take it, or you decide to decline it, right? It's all within a specified time frame, so you can have this setup of treatment periods and burnouts where you can really have this time-centric view of flipping back and forth between your test and control. It doesn't work as well when we talk about a billboard because that's a lot harder to flip back and forth, and people aren't going to be exposed in a really direct way and measurable way in that example. So when we have these different contexts with kind of the same issue, we have these different approaches at our fingertips, and it kind of really depends on the context what we might choose to do in a situation. Another thing that's really exciting to deal with different problems is that same problem of ROI that we were talking about with, say, a marketing campaign. We can also bring that same concept of ROI to investments that you make in your product. It takes real engineering time to drive down the latency of something, right? It takes real effort to build new features. So when you have something that you can model with an elasticity test, it can be really powerful to help you understand how much bang for my buck do I get when I'm making these big investments. In this example, if we talk about decreasing load time, which I think we can all agree is helpful, we might look at our user metrics to see how helpful is it really, and be able to understand how much we want to invest here and how helpful it is. There is also kind of a twist to elasticity tests, is that you can do a regression experiment. These are pretty controversial, actually. I know there are some companies that just don't do regression tests. I know Snapchat just doesn't believe in them. Why would we make a user's experience worse on purpose? But the trade-off there is that you get a lot of information from making a user's experience worse in this case. When we think about load time, maybe it's not so bad, right? It's a little annoying, but I'm not gonna stop using something because of it taking 10 seconds to load instead of 9.87, right? So you can kind of model this elasticity of behavior, hopefully without churning your users. And so that's the trade-off when you're trying to think about running a regression test. Is it worth what you learn to potentially have negative business impacts while you run this test? I'd also like to finish by talking about some of our options for jet fuel to be able to make decisions faster, right? I'm sure we'd all love to make our experimental decisions in an instant, but it's not as simple as that, right? I think one really great technique for this is using SPRT. because what you can do is define your likelihoods ahead of time of what you find believable to accept the null hypothesis or accept the alternative hypothesis. Instead of your traditional frequentist testing, where you're looking at confidence intervals, but you don't have that true negative case of like, hey, there's actually no change here. SPRT helps you quantify a likelihood where if you observe certain things, you're pretty convinced that there is no difference, right? It's a way to formalize that kind of understanding that frequentist analysis doesn't offer. And when you're formalizing that ahead of time, it can let you make those decisions earlier, because when you're trying to do no harm, it's less of an interpretation after the fact and more of a ground truth that you can measure based on assumptions you're willing to make beforehand and based on thresholds you're willing to set. Another really exciting technique that I really like is using a bandit approach. There are a lot of options when it comes to using a multi-arm bandit, but at the end of the day, the point is you can learn really quickly when something doesn't work or when something starts to look a lot better than the others. And it's really painful to be serving people a subpar experience when you already kind of know what you think works. So what bandits do that's really powerful is if we're tracking our probability that a certain variant is the best over time, isn't it great to be able to set our rate of assigning people to that group to the same value? This is just one example, Thompson sampling of this. There are many different approaches, but at its core, it's understanding that you really don't want to send people to a variant that you already know isn't the best. I want to leave you with my 10th experiment, my 10th and final experiment, interleaving experiments. I really see this being exciting for AI use cases, because when we typically think of interleaving experiments, we're going to think about search, we're going to think about ranking cases, and we think about interleaving those results. But if we think about the n=1 case of this, it's just asking people to choose between two options. And I think that's a really powerful use case that we've already seen different LLM providers take to get feedback on their models, right? It's the n=1 case of interleaving experiments to be able to randomize the order that you show things and understand how users click on things, what their downstream behavior is for those different arms of the experiment. Maybe more important for search and ranking, a byproduct of that is getting a search cost for users. Maybe not so deep at the n=1 case, but that gets to be really important for when you think about search engines who want to know, are people actually going to scroll? Are people actually going to move to the second page of search results? And understand what that actually looks like in a user base. So with that in mind, we have 10 different types of experiments that we talked about. I'd love to get an understanding of how many of these experiments people actually are running or have run. I'd love to get the audience standing up. If everyone could stand up, that'd be great. I do actually want you to stand up. Yeah, I know. And then if you've done 4 or fewer of these experiments, please sit down. If you've done 6 or fewer, please sit down. Okay, if you've done 7 or fewer, sit down. 8 or fewer? 9? 10? Have you guys all done all 10? Nice, okay. I'd love to ask the people who are still standing, what's your favorite experiment from this list? If you're willing to share, yeah.
I would say the sequential testing.
Sequential testing?
SPRT, yeah.
SPRT, yeah.
Yeah.
Why do you like it so much?
It's a lot of people think that you really need to wait until the end to make certain decisions, and they're really not paying attention to how much harm a certain experience is making, just because they want to stay statistically rigorous, and they're not really aware that that's also statistically rigorous.
Yeah, I think it's really powerful because it forces you to really do the work ahead of time of setting up a power analysis, understanding your metrics, defining what you care about, which hopefully we're all doing for all of our experiments, but when we think about it practically, that level of care and rigor isn't always applied to a standard A/B test, but SPRT definitely forces you to do that because it's part of the methodology to do it.
Totally. Early stopping is very important when warranted.
Yeah.
Yep. Thank you.
Would you mind passing it to the woman to your right, who also had done all of them? What's your favorite?
I don't think I have a favorite. I think I like that when you are testing a product, you want to intermix the different experiments so that you don't get stuck in a conclusion that you go down a rabbit hole. So I don't have a favorite.
Mm-hmm.
It
is the classic data scientist answer, I feel like, of it depends. But it is so accurate because it does depend on context, right? Yeah. Okay, I think that's it for me. Thank you so much for your time. I really appreciate it. Yeah.